Once you've figured out how many different subnets you've gotten and you've broken everything up, you need to figure out the value of the actual subnet itself. This is the value that is assigned to the subnet. If you look at the way Cisco words it, sometimes they'll say the value that's assigned to the wire. So if you look at the wire that the computers are connected to on the network, this is what we're talking about. Now I've got a rule of thumb that makes it very easy to identify what the range for each subnet is going to be. If we put our chart here that has our values for our bits, and we look at the last bit that's borrowed whenever we borrow bits, and the value that falls into that particular place, that's what it's going to increase by. What I'm talking about is this. If we borrow 2 bits, this is the first bit we've borrowed, this is the second bit we've borrowed, your networks or subnetworks will increase by 64. If you borrow 3, this is the last one that's borrowed, your subnetworks will increase by the number 32. So for instance, you may start out with a 0, the next one is going to be 32, the next subnet is going to begin at 64, and so on. And it'll work down the line. If you borrow 4, it'll increase by 16, 5, 8, 6, 2. Let's look at an example so this can make a little bit more sense. Let's say that you're assigned the network of 193.190.195.0, and you determine that you need to borrow 4 bits. Since this is a Class C address, our default subnet mask is going to be 255.255.255.0. We put our chart out here and say we're borrowing 4, so we go 1, 2, 3, 4. The last one that's borrowed is 16. So if we look at our possible subnets, the original number that we were assigned is 193.190.195.0. The last item is the item that we are using for our subnets. As I said before, we've borrowed 4 bits. It's going to go up by a value of 16, so it goes up by 16. So our first subnet is 193.190.195.16. The next ends in 32. We work our way up, 48, 64, 80, 96, 112, 128, 144, 160, 176, 192, 208, 224, and then lastly 240. 240, as well as the first one, I haven't read. The reason why is you lose the first and the last. This item is lost. This is not a usable subnet. And this top item here is not a usable subnet as well. Once we determine where our networks are going to begin, we go on and we determine the range of addresses that we can actually assign to computers. We're doing all this and breaking this up, but let's look at some practicality. What are the actual computer addresses going to be? Now, here's the subnets that I showed you just a moment ago. We lost the first one, the 0, because that's not usable, and we lost the top one, the 240, because that's not usable either. Here we have the subnet. This is the actual subnetwork address. We cannot assign this to a computer. This is a number that's lost. So our range is going to start the next number up, the 17. It's going to go to 30. Even though the next number starts at 32, if we have our network subnetted and the computers are looking at the subnet mask and they see that you have an address that all ones are put into the host area, and that's what this here is going to do. This is going to put all ones. If it looks at that, what it's going to do, it's going to say, oh, this particular address here is a broadcast, and it's going to send it to every computer on that subnet. So 31 is a broadcast address. Let's look at the next one up. It starts at 32 because this is the value of our subnet, just like we talked about earlier. We can't use this to assign it to a computer. This is assigned to the actual subnetwork. So we start at 33. Even though the next one goes up to 40 or begins at 48, we cut off our last computer address at 46, because if we put 47, what we'll find is this is the broadcast. Okay, 48 begins at 49 through 62. We lost the top one for broadcasting, and we technically lost the bottom one for the line or the subnet work itself. Okay, for 64, we've lost this. This is the actual network address, broadcast address. So we have the ranges in between here. We could work our way all the way down the line here. So our last usable subnetwork, which is .224, this cannot be assigned to a computer. This cannot be assigned to a computer as well. So in summary here, we borrowed 4 bits in a Class C network. This gives us 14 subnets, and if we look at our number of hosts, we'll find out that we have 14 hosts in each. Now, an item I have right down here, it says set the first couple of addresses aside for your routers. If this is your network, as far as what you can assign, what you should do for ease of you keeping up with everything, look at how many routers you have on your subnet. If you have 2 possibilities, reserve 17 and 18 aside. If you form this habit, it will always be easy to get an idea of, okay, what are the possible router IP addresses? Always leave the first couple, or if you may have 3 or 4 routers hitting your network, assign the lowest numbers for the routers. Now, under calculations, if you go to the stuff folder, you'll see a HTML document that you can open up with the browser that's called O5 space ranges, O5 ranges, and this will have this particular item. And under the calculation, I'm asking that determine the subnets and the address ranges for the following. Here's the address that you're assigned, and you're borrowing 3 bits. In the next segment, I'll go through the solution for this particular calculation.